そういったものをお互いに高め合うことによって開発はしてますので、お互いに刺激し合ってものづくりをしているというのが答えになると思います。
Most people, when you think of a forged golf club, what comes to mind is getting the form of the club head through pounding. People might think that it's not a very precise process. The way we do things here is it's extremely precise, and the final shape is basically the final shape. This is where it all starts. These are the raw materials. They actually start off as an ingot, a very large ingot, and then these are extruded into their rod form. And that's kind of where the grain flow starts. As it goes through the extrusion process, those grains are being fed through the extruder and they start to align. And that's going to be very important throughout the process, how we accentuate that grain flow. 241 uses the material that I would say we've been using the longest, which is our 1025 mile carbon steel. It is an elite version of that material, and we call it elite because of the very, very tight tolerances we have in terms of what goes into making a mild carbon steel. So we can have a very consistent material, whether it's from set to set or head to head within a set. It's all very, very consistent because of that elite status of the material. The Mizuno Pro 243, which is our high performance shallow cavity back iron, the material choice there really is more about the material properties itself. We're looking for high strength, but we're also looking for a material that has enough elongation that we can forge an entire head out of it. The material has to have the property where it can spread out throughout the mold and be able to form an entire head. So that's why we use the 4120 material, which has a little bit less carbon in it than the material that we use for the 245 model, which is the 4135. The higher the carbon, the more difficult it is to spread out on the mold, but the stronger it is. But Tomo, don't they use different diameter for different clubs within the set?
Yeah, they can optimize the meat flow by changing the diameters. So smaller diameter for long iron, mid irons, larger diameter for short irons, pitching wedges.
Once these are cut into billets, they're going to be sandblasted perfectly clean. And as they go into the primary forging process, they're actually heated up to 1200 degrees Celsius, where any other kind of impurities are just going to melt right off. And just to kind of give everybody a sense for how many heads we're looking at here, each rod can produce approximately 50 golf club heads, and these come in bundles of 80, I believe.
80, yeah.
So each one of these bundles, you're looking at roughly 4,000 golf club heads. Inside the factory here, they can make about 4,000 to 5,000 heads per day. This is the tooling room, and here at Chuokoyo, they actually have 4 dedicated CNC machines for making molds. How many molds it takes for one set of irons, it could be as many as 30, right? So that's a lot of CNC time. These machines are running continuously, and that's something in product development that we have to be very cognizant of, is how many forged models can we actually create the tooling for. Some people are curious about, how many heads can come off of one mold. And the average number of heads is typically around 4,000 to 5,000 heads. And that includes refreshing the mold every 1,000 or so hits to make sure that the geometry is exact, make sure every radius is exact, making sure that the final product is exactly what we want it to be. There is a tooling life. What we're looking at right here is the Mizuno Pro 243 7 iron EDM tooling, and over here you've got the CNC machines, and they're making the tooling, the molds for the overall head. In the case of EDM, the reason why we use that, we use it for the score lines. So we want to be able to, within our precision forging process, stamp or press the score lines into the head, which means we need extremely tight tolerances in terms of the geometry of the score lines, right? There's rules that govern the scoreline geometry, and we want to be able to go up to the level where we have the appropriate amount of spin, but make sure that nothing illegal is going to happen. So that's why the EDM process is used for creating the score lines on the tooling using this machine right here. What we're seeing here, actually what we're feeling too, you can feel it on the ground. You can feel the vibrations when this press is hitting. You can feel it on the ground. Right here is the primary forging process. It's the same process we use for all models, whether it is the 241, the 243, or the 245. What you're looking at is a 3/4 ton air hammer press. They call it air hammer press because it's pneumatically controlled. The craftsman who's operating the machine right now is actually using a foot pedal to control the height of the hammer press. The first thing he does when he grabs that glowing hot billet is he puts a fin into it. And then there's 3 more shots of the hammer press. Each shot, the material is spreading out more and more into the hole. So we're working the material and allowing those grains to flow into place as it's being hammered those 3 times. Okay, so now we're looking at it from a little bit different angle. You can see a little more what the craftsman's doing. And this is actually a very skilled position. It's a long training program of about 3 years before the craftsman is able to actually work the press. As he's working the press, you can see a little bit more from this angle how he's working the foot pedal to raise up that hammer press to a certain height, and he's watching to make sure that the material is filling the mold and very uniformly to ensure that grain flow. Very similar process, it's almost the exact same process for all 3 models. The 241, the 243, and the 245. Really, really just feel it when that hammer press hits, the vibration in your body, which produces with such force. I think this is pretty interesting here because this is what the craftsman's looking at. These are actually starting with the billet, goes through this machine for the stretching, and then the first shot here is bending it, placing the mass where we need it, and again, controlling that grain. And then these are the 3 shots that you saw on that primary forging machine. Bang, bang, bang. And you can see here, this flash material hasn't fully formed yet. So it still needs to flow more. So on the second hit, more flash meat comes out here. And then finally, on the 3rd shot, now the flash meat is complete. And what you'll notice is that there's limited flash meat here. And that's when, that is actually part of our Grain Flow Forge HD, where we actually block some of the flash here so that we can capture a higher density of grains on the club head right there behind impact to enhance the feel further. And then over here, you'll see after the what we call the flash cut, it's basically like a cookie cutter, and we can look at that over there in a moment, but basically it's cut from the flash and the head drops out like that. And then this goes off to be recycled. Okay, so what you're seeing here is the flash cutting process. So after the head comes off the primary forging mold, it has all this extra meat around it, right? So as it's spreading out on the mold, what the engineers are looking for in this flash meat, when they analyze it, they can tell a little bit about the head based on how that material flowed into the flash. So if we have a nice uniform flash meat around the head, we know that we've captured the maximum number of grains within the head. You can see the process itself is kind of like a cookie cutter, where the head with the flash around it is placed on the tooling, and then the press comes down and basically pops the head out, and then the flash meat is thrown in this bin here where it goes to recycle, and the head goes down on a conveyor belt where it lands in another bin where it can cool to air temperature. When we were looking at the primary forging, for all these models, 241, 243, 245, the process was very similar. But after we moved over here to the precision forging building, that's when they start to diverge a little bit. Basically they're same, but once you start talking about different materials like the 4120 chromoly, there are some differences at this stage. Number one, as you're looking at here, the heads are being fed into the preheat furnace. The temperature's a little bit higher than it is for the 1025E mild carbon steel. Because of the properties of the material, in order for that material to flow, it has to be at a little bit more elevated temperature. So if we go around there, we can also see another difference. Again, this is where the process diverges slightly for mild carbon steel versus chromoly. What we're seeing here is the precision forging process of the Mizuno Pro 243. And you can see the craftsman here is taking it from the furnace here at a more elevated temperature, placing it on the mold, and then the hydraulic press comes down, squeezes it, and then you can see a spray quench. So it's shooting water at the face of the iron to cool that part of the iron head down very quickly, locking in that grain structure on the impact surface of the club head to make it stronger, so it can lock it in permanently. We want the face to be very strong, but we still want the hosel to have a certain degree of malleability so that for adjusting loft and lie angle. So we're getting the properties of the material that we want based on this process, the spray quench, the temperature, and the property of the material. We're now on the back side of the precision forging press here, and you can see on the chute right here, the Mizuno Pro 243 heads, after they're forged, they come down this chute and come around here on this conveyor belt, and they sit here as they cool down to air temperature. The last step before we'll go into the quality control room is we got to clean the heads up. So when they come out of off the forging press, they have some oxide on the surface, maybe a little bit of scale on the surface, and what the operator's doing here is he's loading heads onto these trees here, and then once it's fully loaded, this chamber is going to close, and then it's going to get sandblasted. Like the head is going to get sandblasted, and it's going to come out looking very much like this. It's going to be perfectly clean. All the oxide's gone, and it's now ready to go to quality control. This is quite a bit different than the flash cut after the primary forging. The heads are cooled down, the heads are clean and very controlled process, just taking that last little bit of flash that was created during the precision forging process. So you can see that there was a lot less flash than there was after the primary forging. So there was not that much flow of material going through this, but there was very much the tightening and elongating of the grains as they were going through the precision forging with just a little bit of flash meat. Much cooler in here. Oh, okay, so here's the Mizuno Pro 243. This model is probably where we push the technology the most. You can see this little recess area right here. That is the thinnest that we've ever gone in our forging process, close to 2 millimeters. And then we come back and put the micro slot in so that we'll really have the thinnest face that we've ever had in a one-piece grain flow forged head. So, and that's the 4 through 7, which is the chromoly material. Of course, the 8 through gap wedge are the 1025E. but really challenged. And of course, our partners here at Chuokoyo, they push the limits of the technology in terms of how thin we can go on the face, thinner the face, get more energy to the golf ball, higher COR, increased ball speed, deeper center of gravity, ease of launching the ball. So I would say that the 243 is definitely where we push the most on this cycle.
Yeah, I have come here like over 20 times, but every single time when I visit here, I am impressed. But actually, because of the new material and new process for Mizuno Pro 241, 243, 245, this time is actually I was impressed even more than before. Yeah.
What we've seen today, from the primary forging to the various precision forging, how that turns into such a precise final drop, never ceases to amaze me. And the new Mizuno Pro 241, 243, 245, just taking those processes and particularly in the case of the 243 and 245, just kind of pushing them to the limit in terms of what we can do to find performance increases. And that's what's impressed me the most, is just how it happens, and just we continue to push.